Hello, Math 151. Find the critical numbers for f of x equals 7x minus 2 sine of 7x plus 20. That gives a local maximum for f of x. This is a question coming from your activity 7. And let's first take a peek at, the graph of this is something like this. So infinitely many local max and local minimums. So the strategy here is to take the derivative, set it equal to 0, find the critical numbers, and these critical numbers will point out to the local maximum as well as all the local minimums. So how can we decide if I do have a local max or a local minimum? Well, notice that if our graph is concave down, okay, in here and in here, and in here and on, then I have a local maximum. And so in the language of calculus, the second derivative, f double prime, is negative in here. So f double prime is negative here, f double prime is negative here, f double prime is negative here, and on. And so in between, the f double prime is positive, which means that in these places, in these parts of the graph is concaved up, so it points out to local minimum when the graph is concaved up, just like a parabola, just like y equals x squared, that is concaved up, and the vertex is pointing out to the minimum. And if you have a parabola that is concave down, it is the vertex is pointing out to the maximum. So let me go ahead and go to the next page. We said that f of x equals 7x minus 2 sine of 7x plus 20. So f prime of x equals 7 minus 2 times cosine of 7x using chain rules times 7. And so f prime of x equals 7 minus, I do have 7 times 2 is 14. Cosine of 7x is my derivative. So let's set that equal to 0. Set equal to 0. So I get 7 minus 14 cosine of 7x equals 0. I'm going to go ahead and rearrange. So I have 7 equals 14 cosine of 7x equal, 7 equals 14 cosine of 7x. Divide both sides by 14, and I get cosine of 7x equals 1/2. So I had 14 cosine of 7x equals 7, divide by 14. So cosine of 7x equals 1/2. Okay. So here I know that 7x, where is cosine of an angle 1/2? Look at the unit circle. Okay. So it's happening, cosine is 1/2 in pi over 3. And every revolution of that, which is 2k pi or 2 pi k, doesn't matter, or 5 pi over 3, or 7x equals 5 pi over 3 plus 2k pi. So now I'm going to multiply all sides by 1 over 7 to isolate x by itself. I didn't use theta, I used x. I'm more used to that. Multiply by 1 over 7. Now I have x equals pi over 21 plus 2k pi over 7, or x equals 5 pi over 21 plus 2k pi over 7. Okay. So now I know that one of these solutions are pointing out to the local maximum, the other one to the local minimum. But which one? Well, I'm going to try it. So let me go to the next page. We said that previously that f prime of x equals 7 minus 14 cosine of 7x. I'm going to take the second derivative, f double prime of x equals derivative of 7 is 0. So I have a minus 14 is my constant. Derivative of cosine is minus sine of 7x using chain rule times 7. So f double prime of x equals negative times negative is positive. 7 times 14 is 98 sine of 7x. So now I'm going to find out what is f double prime of, remember the answers that we got in here? I'm going to find the f double prime of pi over 21 and 5 pi over 21 and see which one is positive, which one is negative. I'm looking for the negative one because it is pointing out the local max. Okay, so f double prime of pi over pi over 21 equals 98 times sine of 7 pi over 21, and that equals 98 sine of 7 and 21 cancel to pi over 3, and that gives me sine of pi over 3 is root 3 over 2, so root 3 over 2, and that gives me 49 root 3, but it is positive. Okay, so if the second derivative is positive, that means that that part of the graph is concave up and it's pointing out to the minimum. So that doesn't do me any good. Let me go to the next page. F double prime of our second answer, 5 pi over 21 should give me a negative value. 98 sine of 7 times 5 pi over 21, and that equals to 98 sine of 5 pi over 3. So that equals to 98. Sine of 5 pi over 3 is positive root 3 over 2. Oh no, 5 pi over 3 is negative root 3 over 2. So negative root 3 over 2. So that gives me 2 and 98 cancels out. So I have minus 49 root 3. And so notice that the second derivative is negative. So it is concave down. It is pointing out to the maximum. So good, negative. That's what I wanted. Okay, so let me go back to the next page. So theta equals 5 pi over 21 plus 2k pi over 7 is going to point out to all the maximums. And when k is 0, so this part is going to be 0. So when k equals 0, I only have, I apologize, I should have kept using x. When k equals 0, x equals 5 pi over 21. So 5 pi over 21 is the answer to the first part of this question, part A. So part B is B. Find the function value. Find the function value. That means that find y, function value, at the second local max in the quadrant 1. So that means that my graph is going to be like this. You know, I want not the first one, the second maximum. So I do have x equals 5 pi over 21 plus 2k pi over 7. So the first one was when k is 0. Now the second one is, I'm going to say let k equals 1. So that's going to be my second one. So I'm going to have x equals 5 pi over 21 plus 2 pi over 7. And that is the same as saying x equals 5 pi over 21 plus 6 pi over 21. And that equals 11 pi over 21. Now I have to find f of 11 pi over 21. So f of 11 pi over 21 equals 7 times 11 pi over 21 minus 2 times sine of 7 times 11 pi over 21 plus 20. That was my, that was our f of x. And so use a calculator. Here's a TI. And so I have 7 parentheses 11 pi over 21 minus 2 times sine of parentheses plus 20, and I'm getting approximately 33.25122. 33.25122. Okay, I hope you learned something in this, from watching this video. Thanks.